Hi, this is Robert Hansen coming to you from Austin, Texas. I wanted to do a little bit of a video about large-scale scanning of DNS traffic on the internet. Now, I know a lot of people are getting into this. We finally have the computing power necessary at our disposal to do this type of research. So I wanted to put a little video around how to think about storing the data and parsing it and pulling data out. So the very first thing you need to think about is storing the data backwards. It sounds a little weird, but let's say you have a subdomain www.ebay.co.uk as a simple example. So what you'd want to do is actually basically look at it as if you're looking in a mirror and store it exactly backwards. So ku.oc.yabe.www. And there's a reason for that. It's actually more efficient if you sort everything ahead of time and put it in the database in that order. So it's actually sorted by the domain, the TLD and the domain, as opposed to being sorted by the subdomain. So it's much more efficient when you're trying to do matching of something inside of a domain. So if you're trying to find everything related to some domain, it's more efficient. You almost get like a wildcard search for free to sort it that way. And then you can put a % sign at the end and find all the subdomains inside that domain. So just turns out to be much more efficient that way. Who knows, right? Database stuff, right? I'm not a database guy. So the second thing you need to think about is reverse DNS traffic. It contains a lot of garbage data. If you do scanning across the entire internet, you're going to find about 1% of all the traffic contains characters that just, they may not screw up your database, but they might screw up your database. So you definitely want to be smart about it. Either chuck the data wholesale because it is bad data, or if you need it for some reason, keep it, but be smart about how you store it. Make sure you don't just throw it in the database and just hope it works, right? So the next thing you need to think about is when you're searching for a domain, you have to know what a top-level domain is before you can find the domain. So a very simple example is .co.uk. So once upon a time we had this exploit where if you owned ebay.co.uk as an example, you could put JavaScript on that, what would traditionally be called a subdomain off of co.uk, which is the domain, and TLD is the UK. If you put JavaScript on there, you could read all of co.uk's cookies. Not cross-site scripting, just because you own it, right? You could read all the co.uk cookies, so that was bad. We had to fix that one. So what we came up with as a community is something called an effective TLD list. And that contains things like co.uk and other variants. Sometimes it's like 2 dots, 3 dots, 4 dots even. Total, no rhyme or reason to any of it, but whatever. But you have to be careful because there's some special snowflakes out there. There's companies like Blogspot, DNS, or another example, that believe that they have enough customers and those customers need to be isolated, that they would prefer to be thought of as an effective TLD and have their cookies isolated between different instances of their domain, different subdomains, traditionally different subdomains. They're treating them as different domains. So you as a security researcher may not feel that way. You might think that those things are not subdomains, they're not domains, they're subdomains. But either way, you have to be aware of it when you're looking at an effective TLD list, because that will burn you if you're not careful. So the very last thing to think about is when you're looking at the IPs and you're looking at subdomains, there's a one-to-many relationship on both sides. So you can have, let's say, an IP address that points to many different subdomains, pointing to it rather. A good example is virtual hosting. You got DOSRS, Cloudflare, Akamai, big proxies that are pointing a whole bunch of different domains at a single IP address or set of IP addresses. The other way is you might have a single IP address that points to lots and lots of different IP addresses, like Google, for instance, for round-robin DNS purposes. So either way, you can't really use either of those things as a primary key in a database. I know a lot of database guys get angry when I say you don't need a primary key, but in this particular case, it might actually be harder to use a primary key since you have that one-to-many relationships on both sides. You might be able to manufacture something, but it might add a lot of extra overhead to your database to do that. So I've found it's not really that necessary, but I'm sure some database guy will get pissed off at me about that one. So the last thing, if you're doing this type of research, please shoot me an email. I'd love to see what you're up to. All right, hope you enjoyed it.